Alright, welcome back. So I'm going to be going through the BCMCQ because I don't believe we have anyone from AB here, though I am getting a bunch of messages on WeChat at the moment, so I'll check those out. That's our files. Okay. So starting with number 1. We are looking for I'm looking for all values of x for which this would be increasing. What do I need to do?
Integrate.
Okay, so if I'm looking for when this is derive. Okay, so I'm looking for when this is increasing, we need to know about the slope, so I'm going to end up deriving this. If I derive this, what's going to happen?
3x squared 6x minus.
Okay, 3x squared plus 6x minus 9. I need to be able to figure out when this is 0 in order to figure out when our slope changes from positive to negative. So we're going to do that next. I'm going to go ahead and factor out a 3. So this is 3 times x squared plus 2x minus 3. Or x plus 3 and x minus 1. So in this case, our slope changes at x equals negative 3 and at x equals positive 1. And I can test numbers into our first derivative to figure out whether those are changing from positive to negative or negative to positive. On the intervals where this is positive, should be our answer. So if I wanted to test this, when I plug in 0 for my first derivative, what's going to happen to my slope? Will it be positive or negative?
Negative.
Okay, it is negative. Let me change colors. If I plug in 10, will it be positive or negative?
Positive.
Positive. And if I plug in negative 10, will it be positive or negative?
Positive.
Positive again. Okay, so taking a look at our intervals, what should our final answer be?
C.
Okay. It is possible for them to give us this in sorry, I didn't do two things at once. It is possible for them to give us this in interval notation, which would be something like this. So from negative infinity until negative 3, where negative 3 is not included, and then from 1, where 1 is not included, until positive infinity. Your parentheses in interval notation mean not included or plus or minus infinity. And your brackets mean included. Okay, on the xy plane, the graph of our parametric equations has a line segment with some sort of slope. If I want to find the slope, what do I need to do, Kyle?
We'll have to find dy over dx.
Okay, I need to find dy over dx. So in order to get dy over dx, when I've got a dx and when I've got an x and a y in terms of t, what do I need to do?
We must derive.
Okay, derive. So if I derive this first equation, I'll get a dx in terms of t. So what is dx over dt?
5.
Okay, 5 dt, good. And this will be 5 dt over dt, which will cancel, or just 5. For the next one, dy over dt would be
3.
Okay, so then what is dy over dx?
3 over 5, which is a.
Yep. That's good. Okay, for number 3, looking for the slope of the line that is tangent to the curve. So the slope of the line that is tangent to the curve is really just the derivative dy over dx. We do have a point, though, of 2, negative 1. So in order to solve this, what we're going to do is we're going to derive this equation implicitly, and then solve for dy over dx. So if I wanted to derive this in terms of x, what's going to happen?
2y times dy over dx plus 3xy plus 1 cubed
xy plus 1
times
squared times
I squared times x dy over dx plus 1.
xy prime, this is product rule, so plus product rule when deriving this part.
X prime y.
Okay, x prime is 1 times, okay, so this would be x prime, which is just 1, times y. So if I'm deriving in terms of x, that would be dx over dx, which is 1. Where this y prime is really dy over dx, which is what we're solving for. The plus 1 will go away because if I derive 1, I get 0. So that would be plus 0, which I don't need to write. Okay, so that's good for the left side. Right side is still 0. Okay, then I need to plug in our point of 2, negative 1, and then solve for y prime. So I'm going to jump down here, I guess. Eric, over to you. If I plug in 2, negative 1, what's going to happen?
Negative 2
Okay,
prime
negative 2y prime plus
negative 3 squared. Negative 3 squared times 3.
okay, so this would be 2 times negative 1 plus 1 is
Negative
okay, negative 1 squared times
2y prime plus minus
2y prime minus 1. Okay. And we need to solve for y prime, so I'm going to add everything up. So this is negative 2y prime plus, what's going to happen here?
nine.
So I've got 3 times the negative 1 squared is 3. So then I've got 3 times the 2y prime is
6y.
6y prime, and then 3 times the negative 1.
Minus
Okay, so add all our like terms together. I've got 4y prime is equal to 3, or y prime is equal to 3/4, which is D. All right, any questions so far, 1 through 3? Okay, I'm going to swap colors here because this one's a little bit longer. I want to integrate this fraction. Kyle, if I wanted to integrate this, what's the first thing that I would need to try? Or what's the first thing you would try?
I forgot the name, but you separate the denominator to x minus 1.
Okay, you're right. So this will end up being a problem we need to solve with partial fraction decomposition. And the reason why is because right now if we try just the u substitution, then my u prime for the bottom part would end up having a 2x in it, which is the wrong power of x. So I'm going to try to break this apart. If I factor the bottom, what's going to happen?
That's x minus 4. Wait, yeah, x minus 4 times x minus 2.
Okay, x minus 4 times x minus 2. So this fraction should be equal to something over x minus 4 plus something over x minus 2. And we need to figure out what a and b are. So in order to get my common denominator of x minus 4 and x minus 2, I would have to cross multiply, which gives us a new equation. So our new equation here in blue is 1, everything that's on top, should be equal to a times x minus 2 plus b times x minus 4, and we can use that equation to solve for a and b. Okay. So this equation has to be true for all x values. So jumping over to Eric, which x value would you want to plug in first?
4 or 2.
Either 4 or 2. Okay, so we'll make a table here. If x equals 2, then that means 1 is equal to b times 2 minus 4. Or b is equal to negative 1/2. If x is equal to 4, what's going to happen?
1 equals 2a.
So therefore a is...
1/2.
Okay, so that's going to allow us to go back and rewrite our original equation to say the integral from the integral of 1 over x squared minus 6x plus 8 is the same thing as the integral of a times, so that's 1/2 times 1 over x minus 4 plus negative 1/2. So I'm just going to write negative 1/2 times the integral of 1 over x minus 2. Okay, is everyone okay with the partial fraction decomposition part?
Yeah.
Okay, because this is a constant, I've pulled them outside the integral. If I integrate 1 over x minus 4, what's going to happen?
Natural log.
Some sort of natural log. Looks good. So this is going to be the same thing as 1/2 times the natural log of what?
X minus 4 over x minus 2.
Okay, you're right. I'm going to write this out though. So minus 1/2 times the natural log of x minus 2. And what you're doing is some properties of logarithms, I believe. With your properties of logarithms, as long as you've got the same base and you are subtracting, you can combine those two logarithms, and as long as you've got a power, you can put it up. So I would do something like this. This is the same thing as the natural log of x minus 4 to the 1/2 power minus the natural log of x minus 2 to the 1/2 power is the same thing as the natural log of x minus 4 to the 1/2 over x minus 2 to the 1/2, which is the same thing as moving that 1/2 to the top, is the same thing as 1/2 natural log of x minus 4 over x minus 2 plus c. Forgot my plus c's earlier, but that plus c would carry all the way down. Any questions on what we did here? All right. We've got some twice differentiable functions here. I want to know what's going to happen to h prime. H prime prime. So first, if h of x is f of g of x, then Kyle, what is h prime?
H prime is f prime of gx times g prime x.
Okay. And if that's true, then what would h prime prime be?
F2 f prime prime f2 prime
Okay, f
f
prime
second
prime
prime of gx times g prime x times another g prime x plus f prime of gx times g2 prime x.
Awesome. So that was product rule. And now I just got a match. So which one of these letters matches?
A.
A matches. Awesome. Graph. I don't know if I can actually manage to get everything on the screen. So we'll just take a look from here, I guess. The graph of h of x is shown. I want to be able to match this to h prime. So h prime would be a graph of the slope of the graph that you are looking at right now. So what can you tell me about the slope of our graph? What features should we look for in the answer?
Whether or not it's increasing.
Okay, whether or not we are increasing for our graph in the answer would tell us, would be related to the concavity of the graph we're looking at right now. What's happening to the slope of the graph we're looking at right now? Is it positive or negative?
Positive.
Okay, we start out positive from here to, I'm going to say point A. Point B and point C. Okay, so from negative infinity until point A, our slope, which is h prime, should be positive. Okay, where is our slope negative?
B. From A to C.
From A to C, h prime x is negative, and then from C to the end of the graph, h prime x is positive again. Okay, then we can also look at what's happening to our concavity. So where are we concave down and where are we concave up? Let me jump to Eric for this one. So Eric, concavity?
Can you repeat?
On this graph, from what point to what point are we concave down, and from what point to what point are we concave up?
Concave up. Or the first one.
Okay, I'm going to have different intervals here. So these intervals that I've already written are for the slope. But our concavity is going to tell us about the shape of the graph, not whether we're increasing or decreasing. So just looking at this graph right now of h of x, can you tell me where h prime prime would be positive and where h prime prime would be negative? So
A and C.
Okay, A and C are 2 points. I need to have an interval. So on what interval are we concave up?
Negative infinity to A.
Okay, from negative infinity to A, we're actually increasing. So that's our slope, not our concavity. Let me make a chart really quick. Okay, on this side, I'm going to do our slopes. So when f prime is positive, that means we are increasing. Versus when f prime is negative, which means we are decreasing. And when f prime prime is positive, which means we are concave up. And when f prime is negative, which would mean we are concave down. Okay, if I am concave up and increasing, that means I'm curving up as we increase. If I'm concave down as we increase, that means I am curving down as we increase. So notice we're still going up for both of these. So our slope is still positive, but the way that we are going up is a little bit different. If I'm concave up and decreasing, that would look something like this. If I am concave down and decreasing, I would look something like this. There we go. Okay, so looking back at our graph again. From what point to what point am I concave up?
C to infinity.
Okay, you're right, but there's more points, so our start point isn't at C.
B to infinity.
B to infinity, we're concave up. And when are we concave down?
Negative infinity to B.
Perfect. Okay, so with that, we can infer a little bit about the graph that we're going to see. So the graph that I want to match of our derivative is going to have a positive y value up until point A, and then after point C. Our graph is also going to have a positive slope after point B. So our graph does something like this. A, B, C. Okay, which of these graphs do you think match for H prime?
E.
Okay, graph E matches. Taking another look at graph E, we had a positive y value for H prime, which means our H prime was positive from negative infinity to A, which looks good. We changed direction at B, which is talking about our second derivative, or the concavity, since it's the first derivative of our H prime. And we were positive again after C. All right, any questions on 6? Okay. And teams, okay, still just 3 of us. All right, for 7, I'm looking to integrate. If you wanted to integrate this, what would you do first? It's Kyle's turn, so Kyle?
We would integrate x squared minus 1.
Okay, so right now I've got an improper fraction. If we've got an improper fraction, that means our power is bigger on bottom than it is on top. What do I need to do?
Separate them.
I can separate them. Okay, so this will be the integral from 1 to e of x squared over x minus 1 over x. What is x squared over x?
X.
Just x. Okay, so this is really the integral from 1 to e of x minus 1 over x in terms of x. Okay, so what happens when you integrate x?
X squared over 2.
X squared over 2. Okay, what happens when I integrate 1 over x?
That's the Is that natural log or?
Yep, natural log of x. Okay, and I would have a plus c, except we actually have bounds for this one, so I'm going to plug in upper bound and lower bound in order to get my answer. So I'm going to plug in upper bound first. This will become what?
E squared over 2 minus the natural log of e,
Okay. Which is 1. Perfect. Okay, minus
1 squared over 2 minus ln, which is 0.
0, perfect. So I've got e squared over 2 minus 1 minus 1 half. What is minus 1 minus 1 half?
1 half.
Not 1 half, no. Negative 1
Oh,
minus 1 over 2.
negative 3 over 2.
Negative 3 over 2, okay. So that should be our answer. And we match here. All right. For 8, our derivative is sine times cosine squared. And we know y is 0 when x is pi over 2. I want to know the value of y when x is 0. What do I need to do first? Okay, I think we're on Eric now. So for number 8,
Integrate.
I need to integrate. Okay, so if I integrate sine times cosine squared, how would you integrate this?
One third, no, negative 3, 1/3
Uh,
cosine.
I think you. Okay, I think you've got it. But what's my u and what's my u prime?
U is sine x.
Okay, if I do that, if I make u equal to the sine of x, then that means u prime would be the cosine of x, and I'll have an extra cosine. So I need to try something else.
Cosine x squared.
If u is the... If we set u to the cosine of x, so if it's cosine x squared, then this would be 2 cosine x times negative sine x, which is not what we have on the outside of cosine squared. So I've got one more I can try. If u is just the cosine, so just the inside part of that, then what would u prime be?
Negative sine.
Negative sine. Okay, so then this is the integral of negative u squared u prime. Okay, what happens when I integrate u squared?
U cubed over 3.
U cubed over 3, so this is negative u cubed over 3, which is the same thing as negative cosine cubed x over 3 plus c. Okay, but we do have bounds, because we know that when y is 0, x is pi halves. So I can use that to solve for c. When y is 0, x is pi over 2. What is the cosine at pi over 2?
0.
0. So this means this is negative 0 over 3 plus c, so therefore c is 0. So that means y then is equal to negative cosine cubed x over 3 at any point you want. And we need to figure out what happens when x is 0. So what is y when x is 0?
Negative 1 over 3.
Negative 1 over 3. All right. So that's B. Number 9, I've got this flow of oil in barrels per hour through a pipeline given by the graph above. I want to know what's the best approximation of the total number of barrels that pass through the pipeline that day. Okay, so this is barrels per hour in hours. So if I want a number of barrels, what do I need to do?
Find how many barrels are produced in the hour. I mean, in total.
Okay, you're right, but if my graph is in barrels per hour in terms of hours, how do I do that? How do I get from this to barrels?
Find the area.
Area underneath the curve. Okay, so we're going to integrate. So if I wanted a good estimate for the area underneath this, so a close estimate, I might do something quickly like this. Here is a box in green. And here is a triangle in red. Okay, so if I'm going to do that, then what's the area of our green box?
$2,400.
Okay, and what's the area of our red triangle?
600.
600. So our estimate is
3,000.
about 3,000. All right. Any questions on either 8 or 9? Okay. For 10, we've got a particle moving on a plane so that 1t is greater than 1, our x coordinate is 2 cubed minus t, and our y coordinate is 2t minus 1 cubed. I want to know the acceleration vector of the particle. So we were just given a position vector. So if we know the position vector, s of t is t cubed minus t into t minus 1 cubed. There we go. I'm not very good at drawing angle brackets, but so that just tells us that this is a vector. What would my equation for the velocity be at any time then?
3t square minus 1. 3 2t minus 1 times 2. 2.
Okay, 3 times 2t minus 1 squared times 2. And I wanted to get acceleration at t, so we're going to derive this one more time.
6t. 6. No. 9. 24. 15 minus 1.
Okay, you're right. I'm going to throw this over this way, though, I think. So 12, 2t minus 1 times 2. And we'll go ahead and simplify that for one more step down here. So this is... t is... Okay. So when t is 1, what is our acceleration?
624.
624, which is e. Awesome. Okay, a little bit harder. We're told that f is a linear function from 0 to 0 is less than a is less than b. And I want to know what's happening for our integral from a to b of the second derivative. So first, if f is a linear function, then what can you tell me about the slope?
B minus A. The average between.
So all I know is f is linear. So if f is a line, then what can you tell me about the slope?
Y is equal to mx plus b.
Okay, so what do you know about m?
M is the slope. There's a
Okay, so we know our slope is constant as long as we've got a linear function. So the slope does not change. So f prime is some constant. If f prime is some constant, then what can you tell me about the second derivatives? What happens when you derive a constant?
the constant becomes 0 or 1.
Becomes 0.
Depends.
So f prime prime is 0. And then we're going to integrate. So I'm integrating from some positive a to some positive b of 0 in terms of x. What happens when I integrate 0?
0.
0. So in this case, A is our answer. More WeChat messages. That's not somebody trying to get in, so we'll keep going. Any questions on 11? Okay. Jumping down to 12. We've got a piecewise function here. We're told the limit as x approaches 2 should be equal to what? How do we want to solve this? I think we're back to Eric again.
For 2, like minus on top stuff. 2 a little bit less than 2. Something.
Perfect. In order to have a general limit, we have to have two one-sided limits. So we're going to take the limit as x approaches 2 from the left. What's the limit as x approaches 2 from the left?
ln 2.
Ln 2. What's the limit as x approaches 2 from the right?
4 ln 2.
Okay, so what can you tell me about the general limit?
Because 2 stuff is not equal to each other.
Mm-hmm.
Does not exist.
Perfect. Okay, awesome. For 13, we've got a graph of f shown above. We've got a vertical tangency at point 2, 0. So that is here, vertical tangent line. And horizontal tangencies at 1, -1, and 3, 1. I want to know for what values on our interval is f not differentiable. Kyle, what do you think?
I think it's just A.
Just A, okay.
0.
You're right that we are not differentiable at a. Can you give me a reason why?
Because they're not approaching it to the same point.
Okay, so in order to be differentiable, we have to have a general limit and so we have to have, right, like this. We have to be continuous. So that means we have to have a general limit, and when you plug it in, we have to approach the same point. And the limit as x approaches c from the left of the derivative must also be equal to the limit as x approaches c from the right of the derivative. So the slope must be the same from the left and the right. To be differentiable. Okay, so you're right that we are not differentiable here. But we've got one more place. One more place where our second condition is not true.
Two.
At x equals 2, right? So at x equals 2, we've got a vertical tangent line. In order to have a point that is a point of vertical tangency, then our derivative dy over dx would have to be some number over 0, right? Which is undefined. This actually breaks our second rule, because as I approach this point from the left, I'm going to end up at a different number than if I approach that from the right. But anytime that you have a function that's going straight up and down, vertical tangency, our slope will be undefined. Okay, so this is b at points 0 and 2 only. Okay, for 14, I want to know the approximation of the value of sine 1 obtained using a fifth degree Taylor polynomial about x equals 0 for the sine of x. So first, what's our general form for a Taylor polynomial about sine x?
-1 to the power of x minus 1 times x to the power of 2 times n minus 1
Okay.
over 2n minus 1.
You're not wrong. I might need to start over though. I forgot my sigma. So this is -1 to the power of, say one more time.
N to the power, -1 to the power of n minus x minus n minus 1 times x to the power of 2n minus 1 over 2n minus 1 factorial.
Okay, and what number do you want to start n at? 1 or 0?
0.
Okay, so in this case, n is going to start at 1, I think. If we start n at 0, this would be x to the -1 power for your first term, which is too low. I'll also have a negative factorial down here. Okay, so if I want a fifth degree Taylor polynomial for sine x, then sine would be equal to, so my first term would be using your formula. When n is 1, this will be negative 1 to the 0 power, which is 1 times x to the first power, over 1 factorial, minus x cubed over 3 factorial, plus x to the 5th over 5 factorial, and we stop there, because change my notation here. This is our 5th degree Taylor polynomial of x. 5th degree Taylor polynomial, we've stopped there because we are at the 5th degree. So 5th degree Taylor polynomial of sine centered at 0. And if I want to estimate the sine at 1, then I can plug in 1 into our Taylor polynomial and get our answer. So what should our answer look like?
Negative 1 over 3
3 factorial? Okay.
factorial. 1 over 5 factorial.
5 factorial. Okay, what is 3 factorial?
6.
6. And what is 1 times 2 times 3 times 4 times 5?
120.
120. Okay. So that gives us E. Okay, I think I'm going to do 1, maybe 2 more, and then we'll swap over and take a look at a couple of the FRQs. So for the first one, what's going to happen when we integrate? Kyle, what technique do you think we need?
Oh, sorry. I forgot the name. The long interval one. UV minus integral of U prime V.
Awesome. So integration by parts?
Integration by parts. Okay.
And you're right with your formula. What is U and what is V prime?
U is x and V prime is cosine x.
Okay, that looks good because that means in our next step U prime will become dx, which makes our formula less complicated. Will leave us with just a trig function, which we can integrate directly. Okay, so that means the integral of x cosine x should be equal to what?
X sine x minus integral of sine x.
Okay, what happens when you integrate sine?
Negative cosine.
Okay, that was the last integral, so I'm going to add a plus c. This is x sine x plus cosine x plus c. I did not see it on first pass. Oh, B. There we go. Alright. Last one, then I'll go back and I'll check answers for everything, make sure we didn't mess anything up. So for 16, f is a function defined by f of x is 3x to the 5th minus 5x to the 4th. I want to know all coordinates at the point of inflection for f. Eric, what do I need to do in order to find our points of inflection?
Find f double prime.
Okay, I need to get the second derivative, so let's go ahead and I'm kind of out of space here, so I'm going to break this one and we'll write 16 up here so give us some room. F of x was 3x to the 5th minus 5x to the 4th. So what is f prime?
15x 4th power minus 20x cubed.
And f prime prime?
60x cubed minus 60x squared.
Okay, in order to have a point of inflection, I must have a second derivative of 0 and change sign around that point. So I'm going to take our second derivative and we'll factor. What can you pull out right now?
60x squared.
Okay, 60x squared. What's left?
X minus 1.
Okay, so our point of inflection could be at x equals 0 or x equals 1. And I'm going to test into our second derivative to see whether or not we actually change sign. So if I plug in x equals negative 1, what's my sign?
Negative.
Negative. If I plug in x equals 1/2, what's my sign?
Positive. Negative.
Still negative. Weird, right? Usually it changes, but for this one not. If I plug in x equals 3/2, what happens?
Positive.
Positive. Okay, so even though there were more than one point where our second derivative was 0, we only have one point of inflection at x equals 1. And that's because our sign did not change around 0. Okay, so for 16, our only point of inflection is at x equals 1. Okay, I've got an answer key off screen, so I'm going to read from that really quick, and we'll check together. Number 1, Charlie, 2 alpha, 3 delta. Charlie, alpha, delta, that's good. 4 alpha, 5 alpha, 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 okay. 6 echo, 7 echo, 8 bravo, 9 delta. Echo, echo, bravo, delta, okay, good. 10 echo, alpha, echo, bravo, echo. Okay, 10 echo, alpha, echo, bravo, echo. Okay, 15 bravo, 16 Charlie. 15 bravo, 16 Charlie. All right, got everything right. Okay, then Niall asked me to take a look at 2 of the free response questions that were sent to you guys earlier. So I'm going to pull that up really quick. I need to find that. So he sent me Calculus BC 1998 FRQ. And checking WeChat really quick. He wanted specifically number 3 and number 5. Okay. Save and edit for this too. Okay, so question number 3. We have a function that has derivatives of all orders of real numbers. We know our y value, the derivative, our second derivative, and third derivative at x equals 0. I want to write a third degree Taylor polynomial for f about 0 and then use it to approximate f at 0.2. What do I need to do first?
let's set up a Taylor series.
Okay, set up a Taylor series. So if I'm going to set up a Taylor series and we know what our derivatives are at these points, my general form for a Taylor series looks something like this. So I'm going to add up the nth derivative at our center point, which would give us a constant times x minus a to the nth power, and then I would have to divide by n factorial, right? From n equals 0 to infinity. I want a third degree Taylor polynomial, so I'm going to do this until we get x to the third power, and because we're centered at 0, this is just x. We don't have any a's, because we didn't shift our center point. So what would this look like?
5 over, since we're starting at 0, I think, 5 over 0 with factorial minus 3x over 1 factorial plus x squared over 2 factorial x cubed over 3 factorial.
Okay, 5 plus negative 3x to the first power over 1 factorial, plus 1x squared over 2 factorial plus 4x cubed over 3 factorial. Okay, and is our third degree Taylor polynomial p3x of this function that we're trying to approximate. Okay. Then for part B, I want a fourth degree Taylor polynomial for g, such that g of x is equal to f of x squared, about x equals 0. So Kyle had the last one, so I'm going to jump over to Eric. Eric, what do we need to do here? Oh wait, sorry. We didn't actually plug in 0.2. Let me go back. So, sorry, Kyle, back to you.
Oh,
I
think we just, yeah, I think we just plug in 0.2 for x.
we do just plug in 0.2 for x. This is p cubed x. Do we have a calculator for this or not? Okay, we do have a calculator for this question for that year. So I'm going to go ahead and use a calculator for that. 0.2. Okay, so this is 5 minus 3 times 0.2 plus 0.2 squared over 2 plus 4 times 0.2 cubed over 6. So I got 4.425. As our approximation. It doesn't say how many numbers to round off to, but I guess we'll go ahead and do that. Alright, going back to Eric for part B. So I've got a fourth degree polynomial approximation of g of x. What's going to happen here?
Just like x squared in the first equation we got
Right.
to x.
Actually, I'm going to write my top line like this, maybe. So g of x is equal to f of x squared is equal to. So I'm going to go ahead and substitute x squared everywhere that I had an x in my original equation. And we'll simplify while we're at it. So what should I write?
5 plus negative 3x squared plus x fourth to the prime. Not prime.
Over 2 factorial, I'm going to try to simplify, so I'm going to write that as 2.
2
And
plus 4x 6 over 6.
that's good. I only want a 4th degree polynomial about x equals 0, though. So if I only want the 4th degree, then p for of, I'm going to call this something different, maybe. What's after p? Q? Q. So the 4th degree approximation of g of x should only go until which number? Or which term?
The third.
Third term, perfect. So this is 5 minus 3x squared plus x to the 4th over 2. Okay. I'll make a note too, just so they know what that is. This is 4th degree approximation of g. Right. For C, I want a 3rd degree Taylor polynomial approximation for h, where h of x is the integral from 0 to x of f of t about x equals 0. Okay, so this time I want a 3rd degree Taylor polynomial approximation. So I'm going to say R3x is what we're looking for. Okay. Then h of x, they told us was equal to the integral from 0 to x of f, where f was estimated as this. Okay, so starting there, Kyle, what's going to happen when we integrate?
Five x. No, 5t. No, 5x.
This is weird. I'm gonna go ahead and use x anyways. Even though I've got the same variable here, I guess. All right, I'll go ahead and change variables. That makes more sense. So I like your call better. Okay, so 5t
5t minus 3t squared over 2
plus
plus t cubed over 6.
okay, plus
4t to the fourth power over
you're right, 4t to the fourth power over
10.
This would be 4t to the fourth power over 24. But those 4s are going to cancel, so I'll be left with just the 6.
Oh.
Okay, and I've got lower bound and upper bound that I need to plug in. So right now if I plug in 0, all of the lower bounds are going to cancel. So this is the same thing as 5x minus 3x squared over 2 plus x cubed over 6 plus x to the fourth over 6. But we only want the third degree Taylor approximation. So what is R3x?
5x minus 3x squared over 2 plus x cubed over 6.
That's good. All right, last one. H is the same as part C, given that f at 1 is 3. Find the exact value of h of 1 or explain why it cannot be determined. F of 1 is 3. Okay, I think I know where they're going with this, but does anyone want to give it a shot first?
Could I?
Go for it.
Since the function is a Taylor series, it can go up to infinity, making the value undefined and infinite. Can that work?
Well, our Taylor polynomial approximations won't go to infinity. Even though you can have infinitely many terms, it's just going to get more and more exact, right? But it is possible for us to have a limit that approaches a set value. So you're right that it cannot be determined, but we need to change your reason why.
Okay.
What was the center point that we created the Taylor series from?
F, is it the parent function? F and x minus a n? Is that what it means?
It was at 0.
It was at 0, okay. So we know f at 0, and now we know f at 1. But we don't actually know f for any values between that, right? We can make approximations for any value between that using our Taylor series, but we don't have an exact value for it. And because we don't have any exact values for any point on the interval from 0 to 1, we can't get the exact value for the area between 0 and 1. So I'm going to try to figure out how I can write that. Let's see, h at 1 would be equal to the integral from 0 to 1 of f of t dt. But only f at 0 and f at 1 are defined. Well, we can approximate f of x on the interval from 0 to 1. as f of x is indeterminate, on the interval from 0 to 1, h of x is also indeterminate. Alright, so I'm going to go ahead and check a scoring guide and we'll see how we did. Oh, come on. There we go. It's a little bit blurry. Can you guys still see?
Yeah.
Okay, cool. First one, 2 points for our approximation, 5 minus 3x plus 1/2 x squared plus 2 x cubed over 3. We've got 4x cubed over 3. But still ended up with the right answer. How did we... Last one was for... Oh, because this is 3 factorial and they just use 3. Okay, so we actually still match. So that 3 factorial would be 3 times 2. The 2 would cancel with the 4 and give us 2x cubed over 3. So we do still match, actually. I think we would still get full credit for this. We didn't simplify by taking out numbers inside the factorial, but our approximation is correct. It just says we are supposed to take one away from each incorrect term, where terms are not incorrect. So I think we still get full credit. For part B, 2 points for the second approximation of f of x squared. 5 minus 3x squared plus 1/2 x to the 4th. Okay, that's the same, so that's 5 points so far. 1 point for setting the approximation equal to the integral. Okay, we did integrate. 1 point for answer, but take out if we have extra terms or incorrect. 5x minus 3/2 x squared plus 1/6 x cubed. Minus 3/2 x squared plus 1/6 x cubed. Okay, that looks good too. For D, cannot be determined. H of x is indeterminate, okay. And 1 point for the reason. We know f of t only for 0 and 1. We only define 0 and 1. Okay, I think we would get full credit for that too. So, I think we've got this. Any questions for 3?
No.
Alright, I think I'm actually going to save number 5 for next class, because we're right on time now. Thank you guys for coming. I do need to ask you really quick if you are willing to change times. Niall told me he's got academy from 1 o'clock to 4 o'clock in the afternoon. Would you guys be willing to push this back to... Let me check what time he asked for really quick. To 5 p.m. for tomorrow?
Is it only for tomorrow? Or continue until the end of this week?
This would likely be until the end of this week, but if that's not a good time, then I can start alternating maybe. So we could do like half the days at 5, half the days at 3. Just trying to get as many people as possible.
I guess I'm fine with it.
So 5 is okay or not okay? Sorry, there's a mic break.
Okay.
Is okay. Eric, are you okay with 5?
Yeah, but yeah, kind
Yeah, kind of.
of.
You guys seem pretty hesitant. Is there a better time that would work for you? He says he's out of academy at 4 o'clock, and it might take him some time to get back home.
Maybe 4:30.
4:30?
Yeah.
Okay. So I'll text him and let him know. We'll try 4:30 tomorrow. And I'll post in all the group chats then. Okay.
Okay.
All right. Thank you guys so much for coming.
Bye bye.
Goodbye.